Hello, I'm James Ingram for AutoControls.org. This is similar to last year's layout shown on video number 805, except this layout is using the NCE Power Cab instead of the regular NCE Powerhouse command station, and we're using 2 turnouts instead of 1 turnout. This is a demonstration using an NCE DCC mini panel to automatically control an S-gauge switcher operating point to point with a pair of turnouts so it can take an alternate paths. This is the setup for this. It's intended to go inside a larger display layout on an upcoming display. Notice on this test layout we're using 1 flyer switch and 1 S-helper switch. I'll do the demonstration of this thing and then discuss more details. I'll start this engine from the left end. The turnouts are straight. When we activate the mini panel, it'll start the engine up and run it to the other end of the track and stop it. Then it'll throw the turnouts to curve, and the engine will reverse direction and come back the curved route to where it's sitting now. The momentum on this engine in the forward direction is set to about a 100. The deacceleration is set to about 15, so it doesn't coast too far and run into the stops at the end of the track. Now the turnouts are thrown to curve, so when this engine starts up in a minute, it'll come back to curved route. On the actual display, this will be a longer run, the 2 routes, the curved and the straight. It's sort of compressed on this test layout, but this is just to get the logic of the system working properly. There, we made 1 complete cycle. Now that'll sit there for a minute, and the process will start over. We've switched engines on the track now. We'll run this engine. We'll use the slightly different program. This will go down to the far end, but instead of the turnout switching to curve as before, it'll come back the same straight track. When it gets back to this end, then the turnouts will switch to curved. It'll go down to the other end on the curved track and return on the curved track. The mini panel has space for approximately 120 commands, and these commands were actually left over from last year's program that did the single turnout in the spurs, and I just added a command to control the second turnout and reuse those commands. It's just an alternate way of running this thing. And notice the turnouts didn't throw, the turnouts remained straight, so this engine will come back on the same straight path that it went down. I've got 3 of these switchers with the flashing strobe light on the roof, and by using different push buttons I can select a different switcher to start it and also to send it to a different part of the little routine in the mini panel that will tell it to either go down the curved path and come back to the curved path, or go down the curved path and go back to the straight path. Now this program just repeated, again it'll automatically keep repeating itself. It'll go down the straight path, return on the straight path, then go down the curved path and return on the curved path. Here's the controls for the DCC system. We put a glass house over just to kind of protect things from any accidental coffee spills or anything. There's mini panels down here on the right side, and this is the snap at the NCE controller that throws the turnout, and this is the other snap at that throws the turnout on the far end. In the center of this layout, running point to point, we've got the DCC system. It starts where the engine is sitting right now, goes down at a turnout. It'll go down the straight path in the rear, go down this little section of track, and it'll come around and stop at this end of this layout, sit there for about 4 seconds. It'll throw the turnouts to curve, then it'll reverse direction and back up and come back up the curved path, which is the track in the front. This is almost the same thing as we did last year, except last year we had 1 turnout and 2 spurs. This year we just added a second turnout, so we've got a siding. Reed switch under the track right about here in the same system of operation. There's a magnet on the bottom of the car which triggers the reed switch, which sends the signal to the mini panel that it knows the train is in that location. Then down at this other end of the layout, there's another reed switch about here where this piece of tape is.
Shows them how to set up an automatic switches. Okay. All of this is computer control.
off here.
That's pretty cool. That looks cool.
One interesting thing about this NCE power cab, it has an amperage display in the upper right corner. If you look on the upper right of this display, it says 0.6 amps, which is, I believe it's telling us that it's sending out 0.06 amps to the layout. The layout in this case consists only of that one diesel idling there. Now what I'm going to do is run that diesel up against the end of the track on the left end, so it can't go anywhere, and I'm just going to crank it up to speed, step 28, and you can see the thing's actually ramping up because of the momentum. There it is. It's about, looks like it's pulling. You can see the amperage is varying, but with its wheels spinning against that end of track stop, it looks like it's pulling about a maximum of 0.3 amps with the at full speed with the wheels slipping. Looking at the parts of the DCC system here, we've got the the NCE power cab, which is sort of like a basic junior command station. It's all together. It's thicker than a regular Pro cab because it actually apparently has some command station electronics in it. That more or less replaces the NCE powerhouse that was used in the previous video. As you can see, comparing sizes, compared to the powerhouse, this Pro cab I've got in my power cab I've got in my hand is significantly smaller. It's also cheaper to buy. It has less amperage. This older unit here, I believe, is good for 5 amps, and the power cab as it comes, I think, is good for about 1.3 amps, and it could be maxed, I believe, at about 2 amps. So just going over the DCC components, here's the power cab, and this is what they call the power panel. It's part of the power cab, and they make a big deal, and it's correct. The power cab has to be connected to the left socket of this power panel, and whatever's connected to the right socket, in this case the mini panel, has to be set at address 3. We missed that point, and we spent a good half a day trying to figure out why our mini panel wouldn't work. Once we set it to address 3, everything worked fine. On the left here where my finger is the NCE switch-it, which basically controls this helper service turnout. And over here on the right is another switch-it which controls the American Flyer turnout down on the far end. And these little round things are extra capacitors that Fred Cupp helpfully added. We needed more current to push the coils of these two turnouts, so Fred just experimented by adding larger and larger capacitors until we got enough amperage to successfully throw those turnouts. Then over here on the right side, this is the mini panel, which is NCE's unit, which is essentially, I guess you could say, you can program it to do automatic controls. It's really designed for more for setting up switching routes, but it can be used for simple automatic control like we're using it here. This control unit is all built on one board. It's about 6 inches wide by, I think it's 13 inches long. And it interfaces the layout with this set of 16 terminals. These actually could have gone out on the layout because they operate off track power. Would have saved a few wires, but it's all here because in this case, this control unit wants to interface with another gentleman's layout for the Toy Train Expo. So the idea is I'll supply the control unit, he supplies the layout, and right here will be the interface. Hopefully he's going to have another set of terminal blocks coming from the layout. We can just connect the two sets of terminal blocks, and once having done that, this control unit will control his layout. This drawing here that I'm going to slide in front of the camera as best as I can, this drawing is the drawing that describes this system. And again, here you can see the interface. What you're seeing on this layout right here is essentially what's uncovered by my hand, and then the layout part will be over here, another set of terminal blocks, and the interface is right here where these dotted lines are. Incidentally, if you want to find this drawing, it'll be available at track2.com/info/805. This isn't the neatest job of construction. I'm sort of a klutz, but it gets the job done. I'm sure this could be done a little bit neater. Now looking at the other parts of this little test layout, what you see here is two essentially stock S-Helper service SW9s. The only change is Fred Cupp helpfully added a rooftop strobe light here to give the thing a little action when it's sitting still. But they have Soundtrack Tsunami sound decoders in them. In this, on the bottom of this one is this one has a magnet on the bottom of the car. The magnet activates the reed switch, which is what signals the mini panel that the train's in a certain position. On this train, the magnet is on the bottom of the locomotive rather than the car. For this type of layout, it works either way. There just has to be a magnet somewhere to signal the reed switch that the train is in a certain position. Looking at the other connections to the layout, this is the power. This is where track power is put into the layout. Over here, this is the reed switch. There's actually I'll lift it up and take it out, the reed switch under the track, and I actually moved this around a little bit between changing trains because this train, the reed switch is under the locomotive. This train, the reed switch is under the car, so the reed switches had to be adjusted a little bit. Then going over, this is a connection to the S-Helper turnout, swinging around to the far end of the layout. Down here, these wires go to this wire goes down to power the American Flyer turnout, and this is the reed switch at the far end. If I pull this out, you can see there's a reed switch under there. Again, this reed switch being activated by either the magnet on the bottom of the loco or on the bottom of the car to signal that the train is there. Standing down at the other end of the layout, you can see the S-Helper turnout at the far end, and coming down here you can see the American Flyer turnout interfaced with the S-Helper track. These are pretty much interchangeable for purposes of automatic control. The NCE Snap-it is happy, once it's got enough capacitance added, it's happy to switch either a American Flyer turnout or an S-Helper turnout. The same command and the same wiring scheme will work for both of them. You can see there's basically 3 wires connected to this turnout. We could pull this thing out, slide an S helper turnout, and connect these 3 wires up, and it would happily control an S helper turnout. The word processing file that documents these commands put into the mini panel for this video number 806 can be accessed using the forwarding link track2.com/info/806. This part of the file shows the memory locations 1 through 10, and this is pretty much the same as last year. We're using these first 10 memory locations to start and stop different locos and send them to different sequences in the operating routine. Here's the routine used on the display. Basically, we start the engine at point A, run it down the straight path to point B, throw the turnouts to curved, and then back up along the curved path. In other words, we go outbound on the straight path, throw the turnouts, come back on the curved path. And basically, here's the commands. I won't go into the details. Those were in video 805, but the commands, we throw our both turnouts straight. We go forward from point A to point B. When we get down to point B, we throw the turnouts to curved, and then we return backward from point B to point A on the curved path. The commands we just looked at were what we would call a sequence 1, the normal sequence that we used on the display. It's also possible to have a sequence 2 that, as shown in part 3 of the video with the Blue Rock Island switcher, where we used the commands from last year that were still in the video. If you look at last year's video number 805, that we had a single turnout with 2 spurs, we basically went from point A to point B, reversed, came back on the same route, threw the turnouts to curved, then went from point A to point C, reversed, and came back on the curved route. Now, you can see possibly if we add this second turnout at the end, we can use the same sequence of commands. All we have to do is add one command, squeeze in one command to throw that second turnout. So doing that, we get a sequence that starts at point A, goes down the straight route to point B, doesn't do anything with the switches, it just reverses the engine and comes back along the same straight route. When it gets back to point A, then both turnouts are thrown, the engine goes down the curved route to point B, reverses direction, and comes back along the same curve route to point A. Then the switches are thrown back to straight and it starts all over again. Here's the sequence 2 that uses the commands from last year. We basically squeezed in a command right here to throw the second turnout at the far end, and down here we again squeezed in a command to throw the turnout at the far end. So how this sequence works, the turnouts are thrown to straight, the train goes down the straight route, gets to the end, reverses, and comes back to the same straight route. Then the two turnouts are thrown to curved. Let's scroll up here a little bit. The 2 turnouts are thrown to curved. The train goes forward on the curved route, gets to the end and reverses and comes back on the curved route. Then when it goes back here, there's a link statement at the end that says link to input 21, which sends it back up to the top, and the sequence starts all over again. So this is the second sequence. Again, this sequence appears only in the video in part 3, where it shows the Blue Rock Island switcher running on my ping pong table, going back and forth using this sequence.